Okay, back for some more proof examples. We've gone over the list in the last video of kind of the ideas that you might want to use when you're doing a proof. Remember not to use properties of equality. So here in number 3, that actually will come up that you want to use a property of equality, but you can't, or you shouldn't. You can't. It's a proof. You can't. So let's see. We have sine x minus sine x times cosine squared x equals sine to the third x. So I'm going to work on the left side, leaving the right side alone. The right side seems more simple. And I see that sine x is in both terms, so I'm going to factor that out. So first step, I'm going to factor sine x. And we wind up with 1 or times 1 minus cosine squared x. Oh, so cosine squared x is 1 minus cosine squared x is actually sine squared x. So, so that seems good. Now, what your tendency might be to do right now is to divide by sine x. Divide both sides of the equation by sine x, but that is a property of equality. So you cannot do that. Don't do that. Don't look at this and go, oh, let me move some sine x's around. I see sine x's on both sides of the equal sign. That will be fine if you're solving equations, although you got to be careful with this because sine x could be 0 and you shouldn't divide by 0 ever. So that would be a problem also. But in this case, we're just going to work on the left side of the equation. We're not going to cross that equal sign. We're not going to use a property of equality. So using the identity 1 minus cosine x is equal to sine squared x, we wind up with sine x times sine squared x. Of course, that equals sine to the third x. And that is, in fact, what the other side says. So we drop our other side down and finish our proof with a nice QED. Okay, so pretty simple proof, factor, use a trig identity, Pythagorean trig identity, and off to the races. Let's do the next page too. While we're here, let's clear this one out, and we'll do number 6. So let's see. What strategies are we going to use here? Cosine squared certainly is the simple side. I wouldn't want to try to make cosine squared x into this complex fraction that we have on the other side. So we're definitely going to work on the right side of the fraction this time. Cosecant, cosine, I don't see any obvious trig identities. There's no powers. I think my strategy, I think I'm gonna go back to my convert to sine and cosine. Strategy number 5. One of my favorites is just to change everything to sine and cosine and pray for the best. So cosecant is 1 over sine x. Cosine is cosine x, so that doesn't need to change. And then the denominator tangent is sine x over cosine x. And cotangent is cosine x over sine x. So if we're going to continue with our simplifying idea, now I might be tempted in the numerator, we basically wind up with cosine over sine. I might be tempted to write cotangent x there, but if the idea was to convert to cosine and sine, I'm not usually going to convert back willy-nilly. I might wind up converting back at some point, but until this thing simplifies a lot, I'm going to leave this as cosine sine. Now in the bottom, we have 2 fractions, and if we had a common denominator, that would really help us. So a common denominator in this case would be cosine x sine x. And the first fraction would need a sine x, so that would wind up generating sine squared x in the numerator. And the second fraction would need a cosine x, so that would generate cosine squared x in the numerator. Oh, I like that. So there's my Pythagorean identity of 1. So sine squared x plus cosine squared x is equal to 1. So now we have cosine x divided by sine x in the numerator. And we have 1 over cosine x sine x in the denominator. Okay, so that's much simpler looking, Since we have two fractions being divided by one another. I'm going to look at that as being cosine x divided by sine x times, so we keep the numerator, we change the division to multiplication, and we change the denominator, we flip the denominator. So cosine x divided by sine x times, instead of 1 over, we're going to have cosine x sine x over 1. Okay, and those signs cancel. And that leaves cosine squared x. And then we look to the top to our left side, and lo and behold, that is what we were looking to get. Cosine squared x, QED, such as demonstrated, and we're in good shape on that one. So there's one more example to do. I'll break that into another video. I hope these examples are clear and helpful. Please notice I am not writing down the side I'm not changing every single time. Please notice that I am writing down very discrete, small steps of, if you will, algebra in going from step to step here, right? Making it very clear what is being done without showing reasons. Now, if you're doing a couple of algebraic moves and it's not clear to the viewer what you're doing, you're not breaking it down enough. So make sure you break down your steps well, please.